Welcome to Mastering Solutions. In this problem, we know that it's a double slit problem, and we want to know what the distance is from the central maximum for the m equals 1 for both of these different colors, the red and the violet. And so the equation that is given to us in the book for figuring out the delta y in this case is delta y is equal to m lambda L over d. So let's see what information we're given so far. We know that m is 1, of course. The lambda, we're given 2. We have red, which is 700 nanometers. And of course, that is 700 times 10 to the negative 9 meters. And we're also given the violet, which is 400 nanometers. And obviously, just as we talked about, that's 400 times 10 to the negative 9 meters. Okay. Now, L, they tell us that it is 0.85 meters from the screen. So the L is 0.85 meters, and the slits in this pattern are 20 microns apart. So D is 20 microns, or 20 times 10 to the negative 6 meters. So we have everything that we need here. And what they want to know is what is the delta y for red, and they want to know what the delta y is for violet. So really, this is just a plug and chug equation. We don't even really have to do anything beyond that. So for the first one, let's do the red. So red delta y is going to be m of 1 times the lambda, which is 700 times 10 to the negative 9 meters, times the L, which we said is 0.85 meters, and that's all divided by the D, which is 20 times 10 to the negative 6 meters. So when we plug this in, we're going to have 1 times 700 times 10 to the negative 9 times the L, which we said is 0.85, and all that gets divided by 20 times 10 to the negative 6, or 20 microns. So the delta Y for this is going to be 0.0297, so we can round that to 0.3. So we have 0.03 meters, and we move that 1, 2, that's going to be 3 centimeters for the delta Y for the red wavelength. Now when we do the violet, so for the violet delta Y, we're going to have all of the same information. The only thing that's going to change is now we have 400 times 10 to the negative 9 meters. The L, or distance to the screen, of course, is the exact same, as is the D spacing, or the slit spacing. And so if we go back to our calculator, we can use the exact same equation. We just need to change this from 700 to 400. And so the slit spacing for the violet color is 0.017 meters, or 1.7 centimeters. So the distance from the central maximum out to the first M bright fringe is going to be 3 centimeters for red and 1.7 centimeters for violet.